unavoidable process of release of the Joule heat. And the heating, first of all, the objects of heating would be the electrons. The electrons which are getting energy, they are not playing important role in creating the thrust, so we kind of losing substantial part of energy. The energy, the fate of this, eventual fate of this energy, some of it would be passed to ions and to final increase of the thrust, but a lot of it could be passed to radiation and so on, like you would have in such a media. So I think in my view, it's based on these general arguments and some intuition. I think this particular thruster, MHD plasma, propulsion would not be usable for major future missions. So let's come back to Vasimir, which is, this is a home place of Vasimir, so I'm not going to teach you about Vasimir, but just comparative advantages of Vasimir compared to all the previous systems. First advantage is no interaction with the walls in the major part of Vasimir, because everything is the plasma heated and accelerated is not directly contacting with the wall, except in the initial chamber where you are preparing plasma before it would be subjected to acceleration and propulsion. But in this particular area, energy content of plasma is not significant, so hopefully it would not reduce energy efficiency substantially. So this is a major advantage. Then there is additional advantage that in way Franklin Chandis suggested to heat plasma and subsequently accelerate, energy is deposited not in electrons, but it deposited directly to ions in the applying special type of RF waves, hydromagnetic or MHD waves, in this case, with a frequency close to resonance frequency of ions, the ion cyclotron frequency of the orbiting and magnetic field. So it immediately changes the picture. You are not wasting energy on electrons. Of course, it dictates a special choice of parameters. You cannot go to very high density, where ions and electrons would be in equipartition. They would collide so often with each other, so finally they will share the same amount of energy, equal amount of energy. But in a practical range of parameters, there is always a big room to create in such a way. Ions pick up energy, accelerated, kicked out of the thruster, escaping thruster, before they will share a substantial part of energy with the electrons. So these two advantages, plus scalability to any arbitrary power applied, possibility to scale it, to design in a special way, it's a major advantage of this particular thing. And one particular problem which Franklin listed several years ago would be the following. The magnetic field is indispensable. It's playing an important role. It protects the walls from contact with the plasma inside the thruster, and it also channels the plasma movement along magnetic field lines. So now imagine magnetic field of the coil. It would be like cylindrical coil. So eventually magnetic field lines from inside the chamber would come back around. So if you would imagine the trajectory of individual particle in such a given magnetic field, so eventually particle would have to come back because magnetic field would guide it, would not let it go to escape from the thruster. And there was a need for special mechanism of decoupling of the plasma from magnetic field. And so we were thinking about different special tricks which could be applied. And until, I think it was about a couple of years ago, we simply realized a very, general, simple fact that the processes in the nozzle when stream of plasma is about to escape from the engine emulates the processes when solar coronal plasma, heated substance, escapes coronal magnetic field and forms the interplanetary stream of plasma away from the sun, which is called solar wind. If one would go to the specifics of the configuration, how magnetic field in the solar chromosphere and corona looks like, there are different type of loops of magnetic field. It's more or less irregular compared to the thruster which we are talking about. But in individual specific area, it would look like exactly like that. So when dynamic pressure of plasma is becoming greater than magnetic field pressure, it unavoidably happens in a certain cross-section of expanding nozzle, then plasma simply escaping from the thruster would stretch magnetic field lines, would carry them stretching to infinity virtually. And without paying much energy price for that, because eventually the energy needed to stretch magnetic field lines is only a small, tiny fraction of the kinetic energy of escaping plasma. So this specific calculations, the conceptual analysis were done by Franklin's team, and I did participate in this particular aspect. And then lately I was working with specific details of such a process of detachment or decoupling taking place with the solar wind. There is a very interesting observational experimental data which spacecrafts, robotic spacecrafts are getting about this escaping escape of plasma from magnetic prison of solar corona at different distances. The the record distance was achieved belongs to Voyager 1 spacecraft. You remember Voyager 1, this grand tour? I think it was launched now more than 20 years ago. And it is very far downstream in the solar wind. And on its way outside of the solar system, it is measuring plasma density, so like, continuing expansion from the nozzle, and magnetic field. So automatically you can conclude about detachment. So now they are in the area. I think the recent position of Voyager 1 was very close to 90 astronomical units, so 90 times distance between Earth and Sun. And magnetic field is very weak. It's virtually already close to interstellar value of magnetic field instead of interplanetary, because while it was stretched, there is also expansion, continuing expansion. And plasma, energy of every individual plasma particle is virtually the same as it would be at the distances of the order of Sun and Earth, because it's already fixed energy, continuing expansion. The only difference of this solar wind detachment process from Casimir detachment process, that in case of solar wind, there is an end to this free outflow of solar wind. This free ride of solar wind ends at the distances where streaming solar wind encounters interstellar media. Interstellar media represents it's the media which fills the galaxy, our galaxy, any other galaxy. It is extremely rarefied. Its density much smaller than density of solar wind, but eventually it can create a serious obstacle. So essentially what was expected, what was predicted a number of years ago by the theorists, that supersonic outflow of solar wind encounters interstellar media and finally would be stopped, converted into subsonic through the special type of the shock wave. And the name which was immediately given, termination shock. The shock which terminates supersonic outflow of solar wind. And there were a lot of debates based on different models when finally Voyager or any other spacecraft would reach the area of the position of termination shock. And there is a claim now by some of the people who had instruments on Voyager that they already have seen crossing of this termination shock for the solar wind. But still, there is a big debate. So coming back to Casimir, hopefully Casimir would go to the media where there is no obstacles, no termination shock. So in this case, it's detachment would be done automatically in a very clean fashion. So as defined in this way, that it would be clean from interaction with the walls, no direct deposition of energy in the electrons in the main part of the thruster, then automatic, given virtually for granted detachment from magnetic field, I think it has tremendous advantage over any other type of thruster. The main issue, of course, would be to heat the ions and to accelerate them would require powerful RF generators. There are a lot of them, most of them were developed in this particular range of parameters for experiments with controlled thermonuclear fusion. This is why Franklin took his knowledge from that field. However, the problem is not simply to generate the RF power, but to find the best configuration, coupling, so this RF energy would be absorbed by plasma with high efficiency. That it would require very accurate fine-tuning in choosing experimental parameters and designs, but I believe it is achievable. I was actually going to use this just for drawings, but maybe the audio interpretation, maybe that was enough. You could understand the image of this type of thrusters. Okay, thank you.
I think we have time for a few questions. Go ahead. Do we have the microphones?
Yeah, I think we need microphone. Yeah, oh, it's coming.
Of the magnetic field lines in the exhaust of Vasimir. Now, what do you see reconnection occurring, and perhaps rather than a continuous flow, more of a pulsed flow? What sort of a dynamic exhaust structure do you think will occur in space in Vasimir?
I think this is a very interesting question. I think in principle there might be some reconnection. And if there will be reconnection, then part of the energy could go back. But so it would require serious analysis. First of all, computational simulation of the whole process of the expansion. Yeah, that's a very critical issue, actually. I was going to show you, to end on some cartoon. I don't know if you have seen it. Sometimes it's very important for us who are working in space to look in this way at what we are doing. I borrowed it from Sam Tink. When he talks about AMS experiment, he's showing this particular cartoon. I hope it would keep us with a sense of humor, but...
Another question over here?
Yes, Doctor, in your opinion, of the methods discussed over these 3 days, which, given the improvements which can logically be deduced in the future, should be able to or be capable of propelling a vehicle to the highest possible speed?
I think if only we can invest some energy and money into developing nuclear power in the category of few megawatts, compact, which could be compatible with mass and this configuration of the future exploration system going to Mars or other planet, then I think Vasimir would be a natural choice for electric propulsion. Otherwise, we would be stuck with conventional combustion. And nobody, of course, would forbid us to use it as an ultimate way of transportation. Probably Mars would be the last stop we can use conventional propulsion in solar system for the price of long trip, tremendous mass, and so on.
Yes, in regards to Vasimir and Hall thrusters, what are any perturbing effects, if there are any, from the space environment on performance, specifically Earth's magnetosphere, Jovian magnetosphere, things like that?
Oh, can you repeat that?
Since Hall thrusters and Vasimir rely a lot on electromagnetics, what are, if there are any, what are the perturbing effects on performance due to space environment, such as like the Earth's magnetosphere or even like a Jovian magnetosphere?
Are you asking about this artificial magnetosphere type thing?
No, with the for example, with the Vasmir, that it uses the magnetic field as part of the injection out, is whether you would expect any type of performance degradation from that being in a space environment where you have other magnetic fields and other electrodynamic fields there as well.
Oh, in terms of environment in the spacecraft?
Yeah.
I think Hall thruster using very weak magnetic field. The existing Hall thrusters operating with a field in the range of several hundred Gauss. It's very small. But of course, there would be no influence on the environment in spacecraft. But since they do not have a prospect to have a big power, they are not players in that games which Vasimir can do. I think in case of Vasimir, with a few megawatt power, magnetic field could be maybe an order of magnitude higher, but there are ways to compensate, to screen magnetic field from influencing the environment of the spacecraft. This is exactly what is done now with AMS experiment. AMS experiment creates magnetic field in a large size cube, couple of meter size, and requirement to screen it, to eliminate outside are very stringent. And I think the engineers at MIT and here managed to do it.
Well, I think his question was, what happens when the plasma exhaust comes out of Vasimir, and does it interact with, say, the radiation belt plasma? Mm-hmm. Was that your question?
Oh, I see. Mm-hmm. Oh, I think that, from the point of view of the spacecraft, it would not have any effect. It's already gone. But for space plasma physicists, it could create an interesting object to study. Such a huge, powerful streams of artificially created plasma with a natural environment. It's a very interesting subject, and it's called, it has a name now, active magnetospheric studies. It's trying to inject electron beams, ion beams, or powerful waves and see how magnetosphere or ionosphere would behave.
Another question here?
Yeah, I believe one of the big concerns with traveling between planets, say from here to Mars, is the radiation or solar wind impacts that it's going to have on the astronauts themselves, the physical. Does the magnetic fields produced by any of these electric engines, Vasimir, for example, does that offer any protection for the astronauts in terms of deflecting particles? And any real good enough shielding?
Oh, I think, of course, if astronauts would manage to get inside the thruster, yes. It could protect from solar flares, with, when the individual energy of the protons would be not that high. But galactic, cosmic rays of galactic origin, especially heavy ion component of it, you would need much stronger magnetic field. Yeah.
Yeah. Do you think what amount of maximum energy can be put out by the Vasimir type of electric propulsion engine in the foreseeable future? And what, in the next 10, 15 years, do you think we can really apply this type of engine for the mission to Mars?
I think at this moment it's very difficult to project what's going to happen because two parallel processes are going on. First of all, kind of, trying to build momentum, with arguments in favor of Vasimir and nuclear power. And in parallel with that, there are experimental, devices, but the current device still at very low energy, low power end. So what is needed, I think, and we already had some discussions with Franklin, and I see now that the team of here, of Franklin Center, now increased its skills in the area of computational and theoretical modeling. I think what I would suggest to do now, to do numerical Vasimir, using all the principles, what we know about plasma, to build computational model going to arbitrary energy. I think it probably could take 2 years if with appropriate efforts. It is not very expensive, and it would help then to project the future of Vasimir and in general this technology. Would you agree with this, John? Yeah, that's, I think that's general feeling now.
Sorry about that. I'm just trying to tie together that cartoon with this kind of question here, your money cartoon. And what size engine in megawatts is practical for use in Earth to Mars or Moon to Mars? And if you use nuclear power, I mean, is that a tremendous amount of mass? How much more mass is involved that has to be moved? And then in terms of the money part, is this hundreds of millions of dollars or billions and billions of dollars that would have to go into the development, the research and development of Vasimir or whatever the system turns out to be?
It's easier to answer the question about the mass than about the money. With the mass, the following. If the break-even would be achieved, that we could have 1 kilowatt of power and its application in propulsion only for 10 kilogram of mass, then 1 megawatt would require 10,000 kilos, so 10 tons. Few megawatts, maybe 20, 30 tons. It would be already appropriate to consider flying to Mars with that. So it would add several tens of tons to the mass of the spacecraft, of the ship going to Mars. It's reasonable, quite. What concerns money, I think it would be much more expensive now to develop nuclear propulsion than Vasimir. Vasimir is using so much of existing technology and hardware which was developed for thermonuclear research. But with the reactor, I think what happened, because of general paranoia about radiophobia, a lot of research and design works were stopped in United States and also in Russia to the degree. And now our skills are quite rusty. We have to recuperate what was going on. The interesting paradox I couldn't explain. I even asked Russian Minister of Minatom what would be his explanation. Russia, former Soviet Union, suffered the biggest disaster, Chernobyl disaster. But radiophobia in Russia is now very weak, and they already announced that they are going to double nuclear power stations in Russia in 10 years. I don't understand why, after Chernobyl, they are much more courageous now. Maybe Chernobyl played as a scare, was overkill, and now they are back.
Any more questions?
Yeah, one more here. You described the exhaust of the Vasimir right here, right in front of you.
What about exhaust?
You described the exhaust from Vasimir as similar to the solar wind, and there's an effect near the surface of the sun that the wind is accelerated to supersonic. And I was wondering if inside the engine it's accelerated to supersonic, or if you could take advantage of the same effect that happens at the solar surface, that it would accelerate that and provide better efficiency.
So actually it would be the same material which you heat and accelerate, but say, I don't know, right now it is not clear what type of gas would be best for such type of machine. Originally, Franklin was talking about hydrogen. Hydrogen probably would be less practical in future because it would consume a lot of energy for ionization. But when you move away from thruster with the exhaust, so you will have just cold plasma. It will be very cold because of the expansion in the opening of this jet cone. And finally we'll have a very cold supersonic stream, that's all, of this plasma created inside. There are candidates, the hydrogen or heavy hydrogen deuterium. There is some interest to work with lithium because it's much easier to ionize lithium. So we will see what would be used. Okay?
Thank you very much.
Thank you. Thank you very much. Thank you. Okay.